I want to run through the solutions for this practice exam, and you'll notice that I go into a little bit more detail. The idea being that I want to make sure you get variants of the questions that I'm going to ask, different variations, different ideas, so that you not only feel confident about the answers to this practice test, but that you have some guides to go into your notes and review other pertinent ideas so that rather than just passing a particular practice test, we really are spending this time sort of summarizing our year in physics and preparing to show what we know. So to begin, we want to know the difference between the force of gravity and inertia. Now, I'm going to start this by answering 1 and 2, and you'll notice I state simple differences, but I don't give a deep answer to the question. And then when we get to number 3, we'll clearly define inertia, and we're going to define a couple of other terms that are not inertia, but will kind of complete our understanding of all 3 of these questions so that we know exactly what it is that we're talking about and why. So first, the difference between force of gravity and inertia is simply this. Force of gravity is simply another term for weight, whereas inertia is another term for the mass of an object. Again, we're not defining things there, we're simply stating differences. And interestingly enough, I happen to choose this question so that questions 1 and 2 are oddly identical. That's not going to necessarily happen on your real exam. But it's a happy coincidence here. More importantly, though, let's actually talk a little bit more in detail about what we mean by the definition of inertia. So first, this is a full definition of inertia. So inertia is the tendency of an object to resist a change in its motion. And what that means is if it's at rest, it tends to stay at rest. If it's moving, it tends to stay moving in a straight line and at a steady speed. So we're going to add the second part, which is this. If an object speeds up, slows down, or changes direction, that is the result of a net external force acting on it. Okay. And that's really the idea. Now, I want to distinguish one more term. So we know what inertia is, and I want to also, off to the side here, I'll do it in a different color just so we know that it's sort of a side note. Let's define what we mean by the force of gravity or the weight. We're going to define that very clearly right now. So Fg, or weight, this is the pull of Earth on an object due to gravity. And I'm going to just say 2 more things. So Fg slash weight is a force, and it is measured in newtons. And inertia, or mass, is measured in kilograms. Okay, and to be clear, and is not a push or a pull, but rather a property of an object. So this thing in purple, this is not something that you would add to your these little notes in purple are not something you would add to your test for any credit. This is us just looking at 1, 2, and 3, and then as somebody who, well, I'm teaching the class, but more importantly, I have things that I want you to walk out of here being totally clear on. These are sort of the ideas that round out this entire section so that you have a full picture of the distinction and the definitions among and between weight, gravity, weight, inertia, mass, force of gravity. We have all this clearly defined now. Okay, continuing on. If the forces on an object are balanced, there are 2 possibilities that will happen. One thing is the object will either remain at rest or it will move at constant velocity. And let's be clear on what we mean by constant velocity. Again, constant velocity means we are moving in a straight line at steady speed. And the forces on an object, or if the forces on an object are unbalanced, the object will. Let's be clear. So the short answer is accelerate, but let's be clear what that means. Acerbate, accelerate. Let's be clear on what that means in a physics class. When we say something is accelerating, there are three things it can be doing. That means it can be speeding up, slowing down, or changing direction, even if that direction change is happening at a steady speed. And I want to make one small distinction here. This is an important one. So if you notice, moving at constant velocity is a kind of moving, and accelerating involves motion. So I want to just make a note here on a common mistake that I see students make. So I'm going to make common student misconceptions. I'm gonna write or type up common student misconceptions, annotate those on this practice test. And the way I'm going to do that is I'm going to denote those in red, kind of as a warning to let you know this is an idea that I see students confuse all the time. So let's be clear. If something is moving, that doesn't mean forces are unbalanced. Okay. It has to be accelerating. Please take note of that, because that's going to actually come up in the problems that we do in the subsequent pages. Meaning, this will be a thing. This is not just a little idea to note off to the side and just sort of, okay, I understand that. This is a thing that we are going to carefully apply to problems. And it means the difference between a correct calculation and an incorrect calculation. This fact here will affect the very numbers that you put into your problems and equations. All right, the last part. An object is pushed from rest on a smooth surface, which is ice, for a small amount of time, and it's allowed to move on its own. Then it hits a rough patch, and we want to describe the motion of the object as it's being pushed, after the pushing stops, and then after it hits the rough patch. So I'm going to break this answer into three parts. So while being pushed, it speeds up from rest. After the pushing stops, now we are dealing with an object that is moving, so it resists that change. It resists any change in its motion since it's already moving. It will continue moving in a straight line at a constant speed, and then when it hits the rough patch, after hitting the rough patch, it will slow down to stop. Excellent. So this is page 1 of the solution to our practice test. We're going to work on page 2 in the next video.